Right. The first rule that we talk about is the commutative law. It's called the commutative law, right? I'm going to give you a formal definition, and then I will give you a much shorter definition so that you will understand how to you'll understand the overall idea of the rule. Right? You do not really need to understand the name of the rule, but you need to understand the basic function of the rule. Right? Exactly what we've talked about in our principles video. You don't need to understand the name of the tool as long as you understand the function and the purpose of the tool. Okay. An operation is commutative. So take down this definition. An operation is commutative if changing the order of the terms does not change the answer. So an operation is commutative if changing the order of the terms does not change the answer. So what does that mean, right? Let's see, what does that mean. If I say, so remember, this is basically talking about order. So in the short form, I'll just say changing order of terms. That's like a short form idea of what this commutative law is about. See, 1 plus 2 is equal to 2 plus 1. I change the order of the terms and the answers are still the same. See, 1 times 2 is equal to 2 times 1. I change the order of the terms and it's still commutative. So therefore, I can say that addition and multiplication are commutative. It's commutative, meaning that changing the order of the terms does not change the answer. So both of these are commutative. Okay, now let's do it. Let's do an example involving subtraction and division. See, 1 minus 2 is not the same as 2 minus 1. 1 minus 2 is minus 1, 2 minus 1 is 1. They are not the same answer. And 1 over 2 is not the same as 2 over 1. So therefore we say subtraction and division are not commutative, meaning changing the order of the terms will affect the answer. So changing the order of the terms will change the answer, so it's not commutative. Okay, then we talk about the associative property. Right, so that's 1. 2, associative law or associative property, whatever you want to call it. An operation is associative if grouping terms does not change the answer. So an operation is associative if grouping terms does not change the answer. Basically, what's the basic idea here? Grouping terms. Grouping terms. So let's look at this. See, 1 plus 2 plus 3, if I put that in a group, is equal to 1 plus 2 plus 3. If I put this in a group, the answers are the same. Irrespective of where I decide to group the terms, the answers are still the same. 1 times 2 times 3, if I group those two, is the same as 1 times 2 times 3, if I group those two. So therefore, we can conclude that addition and multiplication, right, are associative. So grouping of the terms does not affect the answer. So again, remember I said these are just tools. Where we will use them, and again, you do not have to understand the law itself, but where we will use them is very important when we start dealing with more longer format questions and we need to simplify your question. Right? This will be more applicable when we start talking about trig identities next year, where you'll have to think about out-of-the-box approaches to solve the problem. Right? But until we get there, let's not even focus on that. See that 1 minus 2 minus 3 is not the same as 1 minus 2 minus 3. Right? It's not the same. And okay, and now you can see that both 1 minus 2 minus 3 is not the same as 1 minus 2 minus 3. Alright? And if you look at something like 36 divided by 12 divided by 3 is not the same as, I'll put the brackets there, is not the same as 36 divided by 12 divided by 3 with the brackets placed like this here. It's not the same. In this case, we get 1. And in this case here, we get 9. So we can say that subtraction and division are not associative, because grouping the terms differently will change the outcome of the answer, and it will change the outcome. So that's what you need to remember. So far you can see that addition and multiplication are both commutative and associative. And you can see that subtraction and division are not commutative and not associative. Okay. And in the last property, before we start talking about BODMAS, right? I remember this rule. The reason we actually prioritized the brackets first is because of BODMAS. That's something that we're going to discuss next. So this is a rule that you should have from your grade 8 knowledge. But if you don't, I'm going to discuss it in more detail, right? Yeah. And then lastly, we got the distributive law. So distributive law, right? With the distributive law, multiplying a number by the addition or subtraction of a group of numbers. So multiplying a number by the addition or subtraction of a group of numbers is the same as multiplying that number to each of the numbers separately. So let's elaborate on that. So multiplying a number by the addition or subtraction of a group of numbers is the same as multiplying it to each number separately. So A times B plus C, multiplying a number to the addition or subtraction of a group of numbers is the same as multiplying the number to each number separately. This number to each number separately. So that's what the distributive law is. It's a very straightforward law. But this is where things get tricky. When we start involving the minus sign. You see, we say that minus A into B plus C is equal to minus AB minus AC. However, if you have A times B plus C minus, let's say, 4, this is AB plus AC minus 4. Here we have to utilize the distributive law because the minus sign is to the left of the bracket. If the minus sign is to the right of the bracket, here it acts as a separator. So here it's a factor, right? It needs to go into the bracket, so you use the distributive law, right? And here it acts as a separator. Remember how we said that terms are separated by a plus or minus sign? The minus sign only separates a term when it's to the left of a bracket. Right? You need to remember that. So you do not use, right? You cannot use the distributive law here. Right? There's this common mistake that we can take the plus and minus sign to the front and then distribute. That's incorrect. Right? Because if you look at this expression, there's two terms, 1 and 2. Right? And then in this bracket, there's two terms here. So you see how the placement of negative here is very important. So you need to understand that for the distributive law. So now we're going to talk about the next two properties, which is the inverse property of addition and the inverse property of multiplication. When we're working with the inverse property of addition, we make use of what we call the additive inverse. It's basically the negative of the number, the additive inverse, right? So what we're saying is that the additive inverse of 1 is minus 1. You take the negative of 1. Right, the additive inverse of minus 3 will be 3. Okay, so it's the negative of the number that you have. Now this will become very useful when you're trying to isolate variables and solve equations, right? You should have a general idea of what I'm talking about. Okay, right, but basically the idea is, for example, let's say that I have x plus 1 is equal to 0. If I'm trying to solve for x, then I must make use of the additive inverse, but I do it on both sides of the equation. Right now I'm talking about equations, but I'm just bringing I'm giving you the reason to this rule. Right, so then you take the additive inverse on both sides of the equation, and therefore you're left with x is equal to minus 1. With multiplication, we get the multiplicative inverse. So the multiplicative inverse. With the multiplicative inverse is found by taking the reciprocal of a number. So for example, the multiplicative inverse of 2 is half. You take the reciprocal, you swap the numerator and the denominator. So this goes to the top, that comes to the bottom. The multiplicative inverse of 3 is 1 over 3. The multiplicative inverse of 3 over 4 is 4 over 3. Right? So that's basically how we isolate a variable. So for example, if I had 2x plus 1 is equal to 0, right? Then I'll say 2x plus 1 minus 1 is equal to minus 1. Right? Because we are taking the additive inverse on both sides. So therefore 2x is equal to minus 1. To isolate this variable, you make use of the multiplicative inverse. You'll say 2x, you multiply by half on both sides. Right? And therefore you get x is equal to minus half. And that's how you get the multiplicative inverse. The multiplicative inverse of any number is basically the reciprocal of that number, swapping the numerator and the denominator. Okay? Now, it's very important to remember that what the inverse does, it undoes the operation. So remember, eventually when we start talking about BODMAS at the end of this video, BODMAS, we say that addition and subtraction are inverses of each other. There's the reason here. Because to get the additive inverse when you have a plus sign, you make it minus. To get the additive inverse when you have a minus sign, you make it a plus. Right? For example, here, if I had plus 1, then minus 1 is the additive inverse. For example, here, if I had minus 1, then plus 1 is the additive inverse. For division, multiplication is the additive inverse. For multiplication, division is the additive inverse. Right? Because you're swapping it. For example, if you had half, then you multiply by 2. That's the additive inverse for half. If you had 2, then you multiply by half. Right? You're basically dividing by 2 here. Multiply by half, divide by 2 is the same thing. Right? Let me just write that here so you'll understand a bit more clearly what I mean by inverses. You divide by 2. Right? That's very important. So the inverse, you're undoing the operation. So if you have division, you're using multiplication. If you have multiplication, you're using division. If you have addition, you're using subtraction. If you have subtraction, you're using addition. It's very important to remember that that's what the inverse is, right? Because we will talk about inverse functions, you're just undoing the effect of the function. Now, when we talk about reciprocals is just simply swapping the numerator and the denominator. So I had to create that distinction between what's the difference between an inverse versus reciprocal, right? Inverse, you're basically undoing the operation, the effect of the operation. But with reciprocal, you're just simply swapping the numerator and the denominator. So don't confuse those terms. Exactly like how we'll do inverse trigonometric functions, is the exact same idea. We're undoing the effect, right? So those are basic rules that you need to remember, and I hope you've taken all of the notes down. And yeah, that's basically what I just wanted to add. So we basically learned five properties: the commutative property, the associative property, the distributive property, the inverse property of addition, and inverse property of multiplication. Commutative law, again, we're talking about changing the order of the terms. The associative law, we talk about grouping terms. Distributive law, we distribute the term into the brackets. And then obviously the inverse property, we understand. If you're going to undo the effect of an addition, you take the additive inverse, so basically make it subtraction. Undo the effect of subtraction here, like minus 3, take the additive inverse, which will be the plus. Same with multiplication, right? You're just basically multiplying by the reciprocal, right? And that's basically all of the properties that we need to know.